Number 3, use the graph below to fill in the missing values. So they're giving us a function, and then they're asking us a whole whop of questions about the function, about the graph that's on that axis system. Well, how's this going to work? Well, again, the main thing to remember, when you have a normal function, what you plug in is x, what comes out is y, right? Okay, so what does that do with the graph? Well, let's take this graph and let's go point by point. I'm just going to take each of these points that hit on a grid line exactly like those, and I'm going to give the coordinates. This point is over 4 up 0, isn't it? That's the x and the y. Here's another point. This is over 2 up 1. That's the x and the y. See that? This point right here is, what is it? It's over, this is 0 here, huh? Over 0 up 2, that's the x and the y. So in other words, it's like they made a table. That's what that graph is. And you get 0, 2, 0, 2. And you get 2, 1, 2, 1. You get 4, 0, 4, 0. That's the same thing. That's the same thing. That graph, that line that's graphed there, is basically telling us this table of x and y values. You can either put the dots on the graph with the x, y values, or you can make a table. Either way, it's the same information. So do you realize that's what a graph is? I don't know if you've ever thought about a graph that way, but it's good to think that way. It'll help you as you go higher in math and science to think about graphs that way. What is a graph but a bunch of dots? And those dots are each a connection between an x value and a y value. Because every dot on a graph has an x and a y value, doesn't it? The x value is how far over it is from the origin, over 2. The y value is how far up it is from the origin, up 1, over 2, up 1, 2, 1. Right? So one single dot, every one single dot on a graph is 2 numbers, an x and a y, isn't it? So, and I think, well, what about the dots here? Well, I could do that one. It's a little hard to tell the coordinates there. I guess it's half. I guess so. Yeah, whatever. You can, there's infinite. You could go forever. I just did 3. We'll just see if that's good enough. All right, here we go. They're given, this is an x value, right? Remember, with a normal function, what's in is x, what comes out is y. So I know this is an x value. So go up there to the table or the graph. x0 goes with y2. Right? This is the y value. It's right here. x0 goes with y2. Okay, how about the next one? What x value goes with a y? This is a y of 0. Where do you see a y of 0 up here? Yeah, right here. Here's a y of 0. What x value goes with it? 4. Or you get it right here off the table. Same thing. See that? Let's try another one. Now they're going f inverse of 0. So is that 0? Is this 0 being put in the inverse function? Is that an x or a y? Well, so inverse functions, they switch it, right? This is y in here and x out there. So this is a y value of 0. Didn't draw that too neatly. This is a y value of 0, isn't it? And they want to know the x value going with the y value 0. So you see y value 0? Yeah, right here. What x value goes with it? 4. And last one. F inverse of what is 0? Again, this is really y. Even if you think, yeah, but it says x. Yeah, they can call it Joe. It's just a name. We know really what you put in an inverse function is a y value on the graph anyway, or in a table. You can call it X, Y, Z, A, B, C, Joe, Tom, Mary. But really, here's the truth. In an inverse function, what you plug in is a y value on a graph. And what it equals is an x value on a graph. Remember, like I could do the right-left thing. So a normal function, you plug in the left point, get out the left number, get out the right number. For an inverse function, you plug in, oh, I did that backwards, huh? The right number, get out the left number. If that's more helpful instead of x, y, I'm not sure it is. Anyway, long story short, they're saying, all right, so that means this is an x. They're saying Go find the x value of 0. Go find the x value of 0. Well, that's right here. It goes with y2, even though they're calling it x. F inverse of 2 equals 0, you say. Y value of 2 goes with x value of 0. Right there. See it? So there we go. So they're drilling us on the connection between x's and y's, functions and inverse functions.